Hi, this is LexaAI, a legal assistant that helps everyday people understand Sri Lankan law. You ask a question in plain language and it gives you answer drawn straight from actual status with the exact act and section it came from. Let me show you a few real examples. First, family law. Can two people get married without a formal registration ceremony in Sri Lanka? So LexaAI searches the marriage registration audience and returns the exact provision that applies. Shows with its section references so you can always check it against the actual status yourself.
Here's one of lots of people run into. I bought a product from a shop, it broke within a day. What are my rights under Sri Lankan law? LexaAI pulls the relevant provision from the Sales of Good Ordinance and explain it into plain English with the exact section shown so you can verify it yourself. So how does this work? At the center is Legal-BERT, a transform model built for legal text. We fine-tuned it into two stages. First, to learn how to extract answers, then to adapt to Sri Lankan statutes. When you ask a question, LexaAI first routes it to the right area of law. Then it searches about library of 1,000 statute section in two ways at once. A semantic search that understands meaning and a keyword search that catches exact legal terms. It blends both results using reciprocal rank fusion and a cross-encoder then re-ranks them to find the most relevant sections. Here's the important part. Instead of letting an AI make up legal text, LexaAI extracts the answer directly from the real statute. That's what makes it trustworthy. Every answer is grounded in the law, and every answer carries a reminder that this is a legal information, not legal advice. We also experimented with two generative components, an autoencoder that compressed our data actually hurt accuracy, so we removed it. A GAN-based safety gate, which screens unusual queries, had only a small effect on valid answers, so we kept it. We measured every piece and kept only what earned its place.
To ensure reliability and reproducibility, LexaAI follows MLOps best practices. The entire pipeline is automated using GitHub Actions. On every push to the repo, the pipeline first runs our evaluation script, calculating matrices like precision at 5 and logging them to MLflow for tracking. It builds a Docker image tagged with the commit hash, including the fine-tuned Legal-BERT model, ChromeDB embeddings, and statute data. The image is pushed to Amazon ECR. Finally, AWS Systems Manager deploys the new image to our EC2 instance, enabling zero downtime updates. The EC2 instance runs 3 core services. They are the LexaAI Streamlit application serving user queries, an MLflow server tracking experiment runs and matrices, and a CloudWatch agent streaming application and MLflow logs for monitoring. If needed, the architecture can scale by adding EC2 instances behind a load balancer or by adopting managed services like AWS Fargate and a hosted vector databases. Key MLOps principles are followed throughout, including codified infrastructure, automated CI/CD pipelines, versioned artifacts, and centralized login and matrices.
If you look at under the hood, the code base is organized as a clean numbered pipeline. The SRC folder holds each step in order: the passing the status, fine-tuning, and the model, the generating the embeddings, and building the search index, ending with the RAG pipeline that runs the app. The law of itself lives in structured data files and embeddings, and the search index sit alongside them, and the strain model is saved it in on hold because every stage is a separate numbered script. The whole system is easy to follow, rerun, reproduce. The LexaAI aims for the over 70% retrieval precision, flags user liability more than the 80% of the time, and the answers in the second on a normal computer. It isn't lower for the covers the all 6 statutes, but in the real step code in making the law accessibility to everyone. Thank you for watching.